When practicing an instrument, hearing is essential to detect issues. However, some issues are unhearable, that is, hard to detect by hearing alone. While some can be found with careful listening to a recording, visualization can show fine details and provide overviews much more efficiently. We conducted a design exploration to learn how visualization can support different musical skills and how one can design such visualizations. As a result, we contribute 33 designs as well as considerations for future work on visualization for musical instrument practice. In the following examples, we show issues that are hard to hear yet easy to see. We start with note duration. Note durations are specified as part of a whole bar that usually is 4 beats long. For example, a half note is half a bar, and dots add 50% to the duration. We use a pie chart to encode this part-to-whole ratio. In this example, a quarter note was played and is shown as a quarter-filled circle. We can see it was held a little too long. A percentage of the closest note and a rough assessment provide details and guidance. An alternative linear encoding makes comparison between notes easier. Our second example concerns rhythm. Can you hear the issue? Here is how this looks in the commonly used waveform visualization. Initially, the drum is synchronous with the metronome click, but then it drifts apart because the drummer plays slower. Exploiting the repetitive nature of rhythm exercises, we use one row for each repetition. This visually aligns beats and makes comparison between repetitions easier. Because we are only interested in the start or onset of each note, we reduce the waveform to ticks that indicate these onsets. To summarize all repetitions, we apply 3 common visualization techniques: overplotting, a histogram, and a density estimation area chart. We can see how consistent each note is played by how much the horizontal position varies between rows. This visualization can show issues with technique. For example, here are 2 different ways to play the same melody. On the left, the hand moves more than on the right. Here, we can see both techniques played 2 times each. The first produces more unintended double notes, the second more quiet notes. To visually convey what is good enough, we added tolerance areas. For mixed rhythms, for example with different drums, we show separate aggregated facets. Such facets can also show improvement over multiple takes. The next example is accents, notes that are played louder than the rest to reinforce a rhythm. We encode loudness as size and timing as note symbols. For comparison, we include bar charts for loudness and inter-onset intervals and the ticks from before. Next, we look at improvisation to a chord progression. We designed a faceted layout that uses rows for chords and columns for repetitions of the progression. Each note is a rectangle that is colored either by its relation to the progression or duration. The last example we show are instrument-based layouts. Starting from how a guitar looks and focusing on the fretboard where notes are pressed with the left hand, we can simplify the layout to a regular grid for strings and frets. We use a scatterplot that displays each note as a dot. Mapping time to color works for a few bars or notes. For longer timescales, we use facets for each bar. These show whether the improvisation is stuck in a spot only uses vertical or horizontal movement, or varies. For more details, please refer to our paper. You can also try all designs yourself in our web app.